In this video, we're going to look at a common mistake my students have made when adding force vectors. So in the setup to this problem, we're told we're looking at an overhead view of a crate with one force pulling in the x direction and the other in the y direction. And we're told friction is negligible, and the question asks for the acceleration of the crate. So here's the student work for our common incorrect solution. Can you see what's wrong with it? In this solution, we've forgotten the vector nature of forces and simply added their magnitudes together. But the magnitudes of vectors only add together if the two vectors are pointed in exactly the same direction. It looks like the magnitude of the acceleration is computed correctly next using Newton's second law, but there's no direction given because we weren't really thinking clearly about direction from the beginning. Instead, we have to position the vectors head to tail, like this. Now the net force is given by the vector pointing from the tail of the first to the head of the second. And the resulting vector makes an angle of theta with respect to the horizontal. Now we can compute the force magnitude F net using the Pythagorean theorem. So that's the square root of 200 newtons squared plus 150 newtons squared. And that turns out to be exactly 250 newtons. As for the angle, that's given by the inverse tangent of 150 over 200. So that's the angle whose tangent is 150 over 200, opposite over adjacent. And that turns out to be about 36.9 degrees. Now the magnitude of the acceleration can be found from Newton's second law. And we go ahead and solve that for A and write it as F net over m. So when we plug in the magnitude of F net and the mass of the crate, that's 250 newtons divided by 50 kilograms, and that turns out to be exactly 5 meters per second squared. Finally, the acceleration vector must point the same direction as the force vector. All we're saying there is that the object accelerates in the same direction we push it, which makes a lot of sense. So we have our final acceleration in polar form, 5 meters per second squared at an angle of 36.9 degrees with respect to the horizontal. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.